Today we're going to learn about permutations and combinations. It's from 6.7. Now this first part's a little bit a little wordy. You don't have to write all of it down. I'll tell you what I want you to write down, but pay attention. It says we throw around the term combination loosely and usually in the wrong way. For instance, we say things like, hey, what's your locker combination? But what we really ought to be saying is, hey, what's your locker permutation? What's the difference? And what exactly is a permutation? The difference, this is definitely something you should write down. The difference between combinations and permutations is ordering. With permutations, we care about the order of elements, whereas with combinations, we don't. So for example, we might say our locker combo is 5, 4, 3, 2. If you enter 4, 3, 2, 5 into your locker, it's not going to open because it's different ordering, aka permutation. The permutations of 2, 3, 4, 5 are all listed here. So this is all the different orders that the numbers 2, 3, 4, and 5 can be written without anything repeating. So we would say that your locker combo is a specific permutation of 2, 3, 4, and 5. If your locker worked truly by combination, you could enter any of the above permutations and it would open. So let's practice finding permutations and combinations here. All right, so this first one here says, suppose you want to know how many permutations exist of the numbers 2, 3, 4, 5 without listing them like I did above or on the previous page. So how would you accomplish this? All right, so how many numbers could go first? Well, we have 2, 3, 4, or 5. So technically there's 4 numbers that could go here. Okay, well then one of those numbers is going to be chosen there. So then how many numbers do we have left to go next? 3. Again, now one of the numbers will be first, another number will be second, and then we have 2 to choose from to be third, and then we only have 1 left that can go last. So in order to find how many permutations exist, all we have to do is 4 times 3 times 2 times 1. And that's called the multiplication counting principle, or as you might have seen before, a factorial. So it's 4 factorial, 4 exclamation points, how you find that. And we can actually, in our calculators, you could type in 4 times 3 times 2 times 1 and hit enter. And that's 24. Or we could just hit 4, hit the math button, see the PRB, that stands for probability, and option 4, it is factorial. So we can just hit 4 factorial, hit enter, and you get 24 that way. Okay, let's look at other examples here. Okay, so how about this? What if I wanted to find the total number of permutations involving the numbers 2, 3, 4, and 5, but want to include orderings such as all 5s or 2 2s and 3, or 2 2 and then 3 4, where not all of the numbers are used and some are used more than once. So how many of these permutations exist? In this case, it's not the multiplication counting principle. It's not the factorial, because I have 4 numbers I could choose from in my set of 4 first. But because we're repeating, I have another 4 set of numbers I can choose from. And again, because we're repeating, I have another 4 set of numbers. And because we're repeating, I have another 4 set of numbers. So this is 4 times 4 times 4 times 4. Or as we know, repeated multiplication is exponent. So 4 to the 4th power, which is 256. So there's 256 permutations that exist of that source. Okay, let's look at another. So you try, pause the video, try it. How many different orders can 10 dogs line up to be groomed? Okay, pause the video. And it is 10 factorial, which when we type that in our calculator, math over to probability, option 4, it is 3,628,800. Oops. 3 million, I forget what it was already. 628,800. It's a lot of different orders 10 dogs can get lined up. Now in this case, order matters because we have a dog that can go first, and then we have that dog's done, so then we only have 9 dogs that can go second, and so forth. All right, combination. So let's up the ante with a little bit more of a challenging problem. So how many different 5-card hands can be made from a standard deck of cards? So in this problem, the order is irrelevant since it doesn't matter what order we select the 5 cards. But there are still 5 cards that we're making. So we're still going to do 52 times 51 times 50 times 49 times 48. You might say, why those numbers? Well, here's our 1, 2, 3, 4, 5 cards, and there's a 52 deck of cards. So 52 cards could go in this, be chosen here, and then one of those is chosen, so now we have 51 and so forth. So that's 311,875,200 permutations. So that's permutations, not combinations. So to fix this, we need to divide by the total number of hands that are different permutations, but the same combination. So that's it's the same as saying, how many different ways can I arrange 5 cards? Well, we have 5, 4, 3, 2, 1. So there's 5 different ways we can arrange 5 cards. So the number of 5 cards hands combinations is 52 times 51 times 50 times 49 times 48 divided by 5 times 4 times 3 times 2 times 1. The total number we have to choose from, how many we can have in our hand. And you might say, well, how can I figure that out? There's actually a really easy button we can use in your calculator. It's called the combination button. And it's 52 combination 5. So we hit bring this up. We have to hit 52 first, at least with this calculator we do. We go to the math option, we go to probability, and you see that NCR. The fact that I already typed 52 in is in place of the N. And then I'm going to type a 5 in. That's going to represent my R. I'm going to hit enter, and there we have it, 2,598,960. All right, here, 7 yachts enter a race. First, second, and third places will be given to the 3 fastest yachts. So how many arrangements of first, second, and third places are possible with 7 yachts? Okay, here we have 7 yachts, and there are 3 places. Okay, so the first thing we need to ask ourselves is, okay, does order matter here? And yes, it should. It matters who gets first, who gets second, who gets third. So we're talking permutation since order matters. So there are 7 yachts and 3 places. So we're going to try to figure out how many orderings that is. So it's 7 permutation 3. And again, there's a fancy button for that. We hit 7 math probability option 2 is permutation. So 7p 3. And we get 210. So there's 210 possible places for those 7 yachts to finish first, second, and third. All right, now you try. There is a reading list for a course in world literature. It has 20 books on it. In how many ways can you choose 4 books to read? Think about it. I'm not telling you whether you have to use permutation or combination yet. So think about it. Does order matter here? If so, use permutation. If not, use combination. Pause the video, try it. And order does not matter here. So it should be 20 combination 4, and you would get 20 math over to probability option 3. So 20 combination 4, you get 4,845. All right, we have one more example here, I think, that I want to discuss. So here we have 10 candidates are running for 3 seats in the student government. You may vote for as many as 3 candidates. Note, it says as many as. We don't have to vote for 3. We can vote for as many as 3. So in how many ways can you vote for 3 or fewer candidates? Okay, well, think about this. You may vote for 3 people, 2 people, 1 person, or no people. So order doesn't matter because it's just the top 3 are going to get in. So we have 10 combination 3, that's 120 possibilities. Or we have 10 combination 2, that's 45. 10 combination 1, that's 10. And 10 combination 0, that's 1. So to figure out how many different ways we can vote for 3 or fewer candidates, I have to add all of that up, which is 176 ways. Okay, so think about it. What is the difference between a permutation and a combination? And be prepared to answer that question in class tomorrow. If you have any questions, definitely make sure you write them down and you can ask tomorrow. Thank you. Have a nice day.